This one's part 179. And it's line 1880, 3z5b3d, atomic F shell, complex numbers, interval cutting, tensor, 5G Wow Seti. So there's the alien radio signal. We're going to Google the word atomic F shell because it came up in the very first video. And this is B.R. Judd, applicability of the Lie group F4 to the atomic F shell. Abstract says the Quark model of the atomic F shell, in which the angular properties of the states of the electrons are represented by the Quark configuration S plus F4, is generalized by assigning spins 1 equals 2 and 1 to the S and F quarks. This provides 5s plus 3f as a basis for the 26-dimensional irreducible representation of IR of F4 and corresponds to the inclusions F4 contains implies Soy 3 G2 times G2 contains a dash implies Soy 3 dash or times Sol 3. The shift operators I plus OR minus make it possible to connect different IRs of the SO8, such as the 3 IRs of dimension 8, any one of which can be taken to span the 8 states of S plus F, in virtue of the automorphisms of that group. The additional symmetries associated with null triality are thereby assumed. Application of the Wigner-Eckart theorem to SOI 3 provides a new perspective on relations between matrix elements of atomic operators within the F shell. That's from 1995. Look at the date, April 14, 1995. Isn't that funny? It's around the same month, just a different year. And that's from iopscience.iop.org. Okay, I found this little graph here, which I thought was interesting. It says the circle of the center 0 and radius 1 in the complex plane is a Lie group with complex multiplication. Again, in some of the formulas, we have a Z and a W and a Z and a W and a 1 and a 0, so I thought it was kind of cool. Lie group came up before, complex planes come up before, circumference of a circle came up. So these all came up in the earlier videos, and there's the formula for it. Okay. Geometric representation of Z and its conjugate minus Z, or whatever you call that. In the complex plane, the distance along the light blue line from the origin to the point Z is the modulus or absolute value of Z. The angle is the argument of Z. So April 9, 2012, my thoughts. Quote, Hilbert's fifth problem asked whether replacing differential manifolds with topical or analytic ones can yield new examples. Does this still apply? With all the different test results coming up, can you now replace differentiable manifolds and yield some new examples with the new formulas given from the Wow signal? In complex analysis, the complex numbers are customarily represented by the symbol Z, which can be separated by its real x and imaginary y parts, like this. Z equals x plus iy. For example, z equals 4 plus i5. My thoughts continued. Looking at this complex analysis of complex numbers, the symbol for z is 0 according to the Maya math equations. X is the equivalent of E, elementary charge, plus Zi, the corresponding atomic numbers. E for elementary charge, Zi, the corresponding atomic numbers. This has something to do with nuclear fusion. That's all I can say. I don't know why, but that's the feeling I get. So what if Zi equals X plus Yi plus E? In the formulas from Wow, there is something mentions to the power of Y and Y to the power of I. Y to the power of Y to the power of I. Just wondering if this can be calculated, let me know. And if so, what is the correct terminology for it? If not, make up a new equation and give it a name. Google Zi equals X plus Yi plus E. And this comes up. Engineering Analysis with Boundary Elements, Volume 18, Issue 4 from December 1996, from ScienceDirect.com. A generalized boundary integral equation for isotropic heat conduction with spatially varying thermal conductivity, from Elaine J. Kassab and Eduardo Divo. It's the Department of Mechanical Materials and Aerospace Engineering, Institute for Computational Engineering, University of Central Florida, Orlando, Florida, USA. So this abstract is, in this paper we derive a generalized fundamental solution for the BEM solution of problems of steady state heat conduction with arbitrarily spatial varying thermal conductivity. This is accomplished with the aid of a singular non-symmetric generalized forcing function D with special sampling properties. Generalized fundamental solutions E are derived as locally radially symmetric responses to this non-symmetric singular forcing function D at a source point of that. Both E and D are defined in terms of the thermal conductivity of the medium, although locally radial symmetric E varies within the domain as the source point, and this other E thing changes position. Okay? A boundary integral equation is formulated. Examples of generalized fundamental solutions are provided for various thermal conductivities along with the corresponding forcing function D. Here, 4 numerical examples are provided. Excellent results are obtained with our formulation for variations of thermal conductivity ranging from quadratic and cubic in 1 dimension to exponential in 2 dimensions. Problems are solved in regular and irregular regions. Current work is underway investigating extensions of this general approach to further applications where non-homogeneous property variations are an important consideration. So the next thing is going to be Google Wigner-Eckart theorem. This European Journal of Operational Research came up from Science Direct. Theory and methodology, stability analysis for a special interval cutting problem from S. Dempy, E. Mueller. Looks like it's from Germany. For a special cutting problem, we show that it is possible to derive full information about the regions of stability of an optimal solution by a slight modification of a dynamic programming procedure used for solving the unperturbed problem. A simple algorithm for computing the optimal value function of this parametric discrete optimization problem will also be given. This algorithm is based on the dynamic programming idea 2. Then I Google Wigner-Eckart theorem. The Wigner-Eckart theorem is a theorem of representation, theory, and quantum mechanics. It states that matrix elements of spherical tensor operators on the basis of angular momentum states can be expressed as the product of 2 factors, one of which is independent of angular momentum orientation, and the other is Lebesgue-Gordon coefficient. We're going to Google another keyword, spherical tensor operators, and find this math equation to use the UFO ship shell and design. Quote, the tensor's components in a 3-dimensional Cartesian coordinate system form the matrix. And this is what it looks like. So trust the second order tensor, the tensor's components in a 3-dimensional Cartesian coordinate system form the matrix of this and this, whose columns are the forces acting on E1, E2, and E3 faces of the cube. Definition, a tensor of type NMN is an assignment of the multidimensional array. So that's what it looks like. To each basis, E1, E and such, we apply the basis of this to this. Then the multidimensional range of transformation laws of this. Oops, sorry. This is in the way. Okay. That's what it looks like that. Okay, so April 9, 2012, my thoughts. When I look at the cube from the tensor nodes, I think about the middle section of the UFO, the floats in the rotating shell. This section here seems to show what mathematical formulas will be required for that section of the ship. Not sure what the cutting problem abstract means or even what it's for. And just know that the keywords isotropic heat conduction, thermal conductivity have come up in the WOW data before. Again, there's the video you want to start with this particular section is line 18, a3z5b. That's the first video, and then there's 8 altogether that talk about the data from this particular one. So I took all the data from this one and divided it into 8 different videos, okay? And sorry, this is all. I like OneNote, but sometimes it's a pain in the butt. There. So there's our tags there. And these are the words that come up in the videos, okay? So I'm going to stop filming that one.